So let's talk about how we can shift the graph of a function either up, down, left or right without changing its shape. So let's take C a positive real number, and then let's talk about vertical and horizontal shifts in the graph of y equals f of x, and all the shifts are listed down in this table. Okay, so there are two main types of shifts. They are vertical and horizontal shifts. So remember, the vertical shifts actually they affect the output y values, and the horizontal shifts actually they affect on the input x values. So if you have your h of x as f of x plus c, which means you are going to add a constant to f of x, that means your graph will move upward by c units. On the other hand, if you subtract c from f of x, then your graph will move downward by c units. So in horizontal shifts, if you subtract c from x values, then your graph will move right by c units. And if you add c into x values, then your graph will move left. So now let's try some examples, then you will see this concept clearly. So this is the first example that I'm going to discuss. So you have three functions. You have to sketch all these three functions in the same set of axes. So let's start with f of x equals x squared. So this is very easy. F of x equals x squared is a parent function. So you already know this is a parabola open upwards and it's going through origin. So let's take this as the origin. I'm going to zoom this and I'm going to sketch y equals x squared. Okay, it's going to be something like this. So let me name this as f of x equals x squared. Okay, so now let's move into our second function, which is g of x equals x squared plus 2. Okay, so first of all, you have to identify this as a vertical shift. It's because g of x can be written as f of x plus 2 because over here we have taken x squared as f of x, and here I just replace x squared by f of x, and now you can write your g of x as f of x plus 2. So this is a vertical shift, and this is plus a constant, which means this vertical shifts will be upward. And since the constant we have is 2, it's going to go upward by 2 units. So once you identify the shift, what you can do is you can take the same graph. I'm going to copy this down. And then I'm going to move this graph 2 units upward. So here to here, it's just 1 unit. And I'm going to move 1 more unit. So this graph over here will represent g of x. So let me write this as g of x equals x squared plus 2. So here this is called vertical shifts. Next, let's move into the third function that we have, which is h of x. For that, I'm going to use the green color. So h of x is equals to x squared minus 3. Again, you can write h of x as f of x minus 3. So here again, you have to identify this as a vertical shift. And this is, since this is subtract, you have to get rid of this 3 from f of x, which means this is minus. So this is going to be a downward shift by how many units? It's going to be 3 units because the c is 3. So now we have to take our f of x and we have to move this 3 units downward. So here the units are from here to here just 1, from here to here it's 2, and here to here it's 3. So if you move this same exact function by 3 units, you will get your h of x. You don't have to do the calculation. You don't have to do anything. Just what you have to do is you have to copy this down, and then you have to move this graph 3 units down. Okay, I have my function and I'm going to move this 3 units downward. 1, 2, 3. So this one over here, this is my h of x. So h of x is this function. So this is how you do this. So remember, once you get a problem like this, you have to identify whether it is vertical or horizontal shift. So let's try more examples. So let's do example number 2. If you want, you can pause this video and you can try these questions by yourself. Okay, so here also you have 3 functions that you have to sketch on the same Cartesian plane. F of x equals x, g of x equals x plus 1, h of x equals x negative 2. Well, let's start with the first one, f of x equals x. Well, this is we can sketch this very quickly because this is a straight line passes through the origin. So I'm going to sketch this like this. Okay, this is my f of x equals x. Next, I need to sketch g of x equals x plus 1. Okay, so here this is a vertical shift. It's because you can write g of x as f of x plus 1. So remember, so this is a vertical shift, and it's gonna move up by 1 unit. Okay, so so you have to draw the same sketch, same line, but you have to move this line upward by 1 unit, which means, let me copy this. Okay, here we go. Okay, I just copied it, and this is origin, and I'm going to move this by 1 unit. Here we go. So this is 1. So remember, so this is the origin. I just moved the origin by y unit, then it's going to be this point. So this line will represent your g of x, which is x plus 1. Next, let's move into the third function, which is h of x equals x minus 2. Again, here, this is a vertical shift. It's because h of x can be written or expressed as f of x minus 2. So this is a vertical shift downward by 2 units. Okay, so if you move this origin 2 units downward, so it's going to be here and negative 2. So here you have to move this line 2 units downwards. So it should be somewhere here. So let me copy this, and I'm going to move this line 2 units downward. So that's here. So this is going to be your h of x, which is x minus 2. This is example number 2. Now let's move into example 3. So example 3, again you have vertical shifts. So you have to sketch f of x equals square root x, g of x equals square root x plus 2, and h of x equals square root x minus 4. So let's start with first one, f of x equals square root x. Well, if you sketch this, it is going to be something like this. So let me name this as f of x equals square root x. So now you have to sketch the second function, which is g of x. So g of x is going to be square root x plus 2, which means you can write g of x as f of x plus 2, which means this is a vertical shift with upward 2 units. Okay, so let's copy this exact same function and then let's move this 2 units up. So from here to here it's just 1 unit, and from here to here 2 units. So this is going to be your g of x. X square root x plus 2. Now let's move into the third function, which is h of x equals square root x minus 4. So here again h of x can be written as f of x minus 4, which is vertical shift downward by 4 units. It's because you have here negative 4, which means the graph will move down by 4 units. So again, I'm going to copy my parent function over here, and then I'm going to move this 4 units downward. Okay, from here to here, just 1, 2, 3, 4. So this point is going to be, this is the origin. I just moved this origin 4 units downwards. That means from 1 here to here 1 unit, from here to here another point unit, 3, 4. So this is going to be a negative 4, and this function over here you can name it as h of x equals square root x minus 4. Yes, this is the end of example number 3. So now let's move into few examples using horizontal shifts. Remember, in horizontal shifts, if you subtract constant from x values, then you'll get your function or graph move into right. While if you add the constant, then your graph will move to the left. Example number 4. So here you have to sketch all these 3 functions in this Cartesian plane: f of x, g of x, and h of x. So let's start with f of x. So this is going to be easy because this is the parent function, and f of x equals x squared is a parabola open upwards, and it is going through the origin. So let me sketch that over here. Yes, so this is my f of x. I'm going to name this as f of x equals x squared. Next, I'm going to get my g of x. So g of x is x plus 2 to the power 2. So this is similar to f of x plus 2. So here the constant is being added to x, not outside of the function, which means this is going to be a horizontal shift. This is horizontal shift. And since here you have plus the constant, it is going to move horizontal, a left move by 2 units. So in order to sketch this function over here, you have to move this graph horizontally left to 2 units. So what I'm going to do is I'm going to copy this graph, and then I'm going to move this graph 2 units to the left. So if you start from here, and I'm going to move the origin 1 unit to the left and again another unit to the left. So here, if you look carefully, so this is the origin. So here I have moved this origin from here to here, which means 2 units. So this is the origin now. So this graph over here will represent g of x, which is x plus 2 to the power 2. Next, we'll move into h of x. So h of x is x negative 3 to the power 2. Again, this is a horizontal shift. It's because 3 is being subtracted from x itself. It's not outside of the function. So this is horizontal shift, and you have to decide whether it's left or right. Since this is negative 3, it's a right shift by 3 units. So that means you have to move this parent function over here to the right by 3 units. Okay, so that means if you take this origin over here, it's going to move 3 units to the left, which is over here. So you have to move this point into this. So to do that, what I'm going to do is I'm going to copy this exact function, and then I'm going to move the vertex over here. So this curve represents my h of x, which is x negative 3 to the power 2. Moving on, example number 5. So here again you have 3 functions, and in this example the parent function is f of x equals x to the power 3. So if you sketch this parent function, it is of this shape. Okay, it's something like this. So this should go through the origin. So let me move that. Yes. So this over here represents f of x equals x cubed. Then let's move into my g of x. So g of x is equals to x plus 1 to the power 3. Again, so this is a horizontal shift. It's because 1 is being added to x. So this is horizontal shift, and it is going to be a left shift. It's because you have plus over here. So this is left by 1 unit. So now I'm going to take, in order to sketch my g of x, I'm going to take this graph and I'm going to move that 3 units to the left. So let me mark the 3 units first. So if you're considering the origin, you have to move this origin left horizontally by 1 unit. So that means you have to move this point over here. This is where you'll get your 1 unit. So what I'm going to do is I'm going to take this graph and I'm going to move it over here. Okay, so this graph over here will represent your g of x. Next, let's try to get my h of x. So h of x is x negative 2 to the power 3. Again, this is horizontal shift. It's because 2 is being subtracted from x. So this is horizontal, and then this is going to be a right shift because negative 2 and by 2 units. So again, what I'm going to do is I'm going to take my parent function and I'm going to copy this down, and I'm going to move this two units to the left, which is over here. It's because here I moved my origin 2 units to the right. That is example number 5. Example number 6. So you have to graph these three functions. Okay. Well, let's start with the parent function. So here this is square root x. So if you sketch the parent function, it will be of a shape like this. And using this parent function, you have to sketch your g of x and h of x. So g of x is square root x plus 2. So this is again horizontal shift. It's because this plus 2 is being added to x. So here this is horizontal and this is going to be a left shift by 2 units. So what I'm going to do is I'm going to move, let's pick a point. So let's move this origin, the point in the origin, to the left by 2 units, which means you have to move that point over here. So from here to here, just 1 unit, and from here to here, another point unit. So which means you have to move this point over here. So let me copy this. Okay, and then I'm going to move this origin into here. So this graph represents your g of x, which is square root x plus 2. Then you're going to do h of x, which is x negative 2 square root. Okay, again this is horizontal shift, and remember this is going to be a right shift. It's because you have negative 2 here by 2 units. So again, I'm going to copy my parent function and I'm going to move that to the right by 2 units. So this is my h of x. Okay, that is example number 6. Moving forward, example number 7. Okay, so here let's try to sketch this function over here in my Cartesian plane. So remember, this is not like a very simple function, but using the transformation, we can sketch this function. So in order to sketch this function, so let me write my g of x first. I'm going to jot down that first, and then I'm going to break my problem into few parts. Okay, so here I see I have x plus 2 to the power 2 and I see plus 1 is being added. Okay, so it seems like this function is of the format f of x equals x squared. So this is where I'm gonna start. So it's because my given function is of this format. So I already know how to sketch this, which means I have to start with a parabola which goes through the origin. Okay, here I have my parabola. So this represents f of x equals x squared. Okay, so now I'm going to move forward from here and then I'm going to construct this function from my f of x. To do that, first of all, I'm going to construct this term over here, which means, okay, I'm going to name that function as h of x and I'm going to take the first part of my function. So here you can sketch this h of x using f of x. So this is a horizontal shift. So this is going to be a horizontal shift. And remember, since this is plus 2, it's going to be a left shift by 2 units. So what I'm going to do is, I'm going to take my graph over here and I'm going to get my h of x. To do that, I have to move this graph to the left by 2 units. Okay, let me do that. I'm going to take this and I'm going to move this to the left by 2 units. So origin is here. The vertex is placed at the origin. So here you have to move this vertex to the left by 2 units, which means it's going to be end up over here. So I'm going to move this graph to here. So this graph over here will represent my h of x, which is x plus 2 to the power 2. So now I'm going to get rid of this part. Okay. Well, so now we have h of x, but we are supposed to sketch g of x. It's not the same. We are still missing this plus 1. Okay, so now we have h of x. To get g of x, what you have to do is you have h of x and you have to add a 1 to that h of x. So here, if you look at this carefully, this is a vertical shift. So this is a vertical shift. And since you're going to add a 1, so this is a vertical shift and it's going to be upward by 1 unit. So that means in order to get your g of x, what you have to do is you have to move this graph upward by 1 unit. So if you consider about this vertex, so this vertex should move over here because every y value will be moved upward by 1 unit. So I'm going to take this graph and I'm going to move that graph up here. So this graph represents g of x, which is x plus 2 to the power 2 plus 1. Okay, the final example, example number 7. So here, let's try to sketch this gx over here. Again, this is a very complicated function. To sketch this, let's start with this parent function. F of x equals modulus x. Okay, so I'm going to sketch that function first. So it's something like this. It's a shape of a V. So it's going to be something like this. So this is my f of x. So this is modulus x. Okay, so to get g of x, first of all, let me get h of x equals x negative 1, the modulus x negative 1. So we should be able to get h of x using this parent function. It's because we know this is a horizontal shift and this is going to be a right shift because you have minus 1 by 1 unit. So if you consider this origin, it's going to move right by 1 unit. So this origin should translate over here. So what I'm going to do is I'm going to grab this graph and I'm going to move that over here. So this is my g of h of x. So now I need my g of x, which is x negative 1 minus 3. So I already have this function. So in order to get this g of x, what I have to do is I have to do a vertical transformation to this. And the vertical transformation is going to be down. It's because you have here negative and it's going to go down by 3 units. So this is this is the point and you have to move this point 3 units down. So if you move that over here, it's going to be a 1 unit, 2 unit and 3 units. So let's take this and let's move that again down by 3 units. So this graph over here is a sketch for g of x now. So using transformations, actually you can sketch these kinds of complicated functions.